So this week we started looking at quadratic expressions and equations. So what you guys started off with was looking at the graphs and doing a couple videos with some questions on just the different parts of a graph. So as you might remember from those, a graph of a quadratic is a parabola. So it's that U shape. What you started off the week with was a quick warm-up about the standard and factored form of a quadratic. And I was just going through some of your responses for that, and you guys had some interesting insights and completely spot on with what we're going to look at. So first thing, what a quadratic equation is, it's an equation or an expression that has an x to the second power, and the second power is the highest power. Okay, so we're going to kind of look at a couple ideas with those today. So there's actually three forms of a quadratic equation that we are going to look at. Right now, we're just focusing on the standard form and the factored form. Okay, so standard form is anything that's written in this form: y equals a times x squared plus bx plus c, okay, and a cannot equal 0. The vertex form we're going to talk more about next week, so I'm not going to worry about that now. And then the factored form would be y equals a times x minus p times x minus q. So what a lot of you guys notice when you're looking at the standard form is that it's going to be written as a polynomial, and you're going to see an x squared in it. The factored form is a multiplication problem. It typically has parentheses around the different parts, or the different factors, as they would be called. And we're going to look at how that relates to the graph and how it relates a little bit with algebra. Before we get into that, I just want to kind of bring your attention up to this picture at the top. So we have an upside down parabola here, and there's a few key parts that are labeled. So first is this x-intercepts. So where the graph crosses the x-axis, just know that these also have two other names. Sometimes they're called roots, sometimes they're called zeros, all talking about the same thing, all talking about where we cross the x-axis. The other thing up here at the top, on the y-axis, we've got the y-intercept. So where your graph crosses the y-axis. The y-intercept always happens, just so you know, when your x is equal to 0, and I'll mark that on here too. X-intercepts, they happen when your y is equal to 0. They also have labeled up here at the top, this is your vertex. Okay, the vertex is sometimes called the turning point. It's where your graph would change directions. So what's a little different about a parabola is, in this case, it comes increasing, gets up to this top point, this vertex, and then it turns and goes back the other direction. So it's different than a line, different than an exponential graph that we spend a lot of time with. The last thing that this graph doesn't label, but I'm going to now, is the axis of symmetry, because we're going to talk about that today again. So the axis of symmetry is this invisible line that cuts right through the middle of the parabola. So if we were to fold this on a piece of paper, we could fold one side of the parabola on the other. So the roots, or the x-intercepts, are always going to be the same distance from that axis of symmetry. Okay, the axis of symmetry also goes right through that vertex. Ooh. Let me just fix that. Axis of symmetry. Okay, so we'll talk more about the forms and you'll see them, but I thought they were kind of good to include in our notes. So how to tell if something is in the factored form or the standard form. This is what we started our week off with, and you guys got it right away. Okay, so when we have factored equations or expressions, okay, so factored equations or expressions are going to have your parentheses, okay, and in a quadratic, you're not going to see an x squared. So if we look down at the bottom, this first example down here, negative parentheses x plus 4 times x minus 5, this is a factored expression. Versus when you have something in standard form, that's when you're going to see the x squared, okay? And these ones don't have parentheses. They're written so they look like polynomials. So this one is your standard form. So just how to tell them apart. And with these, both the factored and the standard form, they tell us some different information. This we'll see again next week, but I just felt like I would include this so you guys have it in your notes, and you will get a copy of these notes as always. Okay, and I'm going to jump down here. So a visual representation, what does this mean about the graph? So here we have a graph, so a picture of a parabola. I can see that this is a right side up view. I've also got two different equations here written in function notation. So the first one in standard form, f of x is equal to x squared plus 3. And then down here, it's the same, it's the factored form of the same equation. F of x equals parentheses x plus 3 times x plus 1. So we're going to find these parts on our graph, and then we're going to relate them back to those two forms up on top. So first, x-intercepts. Okay, so the x-intercepts I'm going to find from my x-axis, so where I cross my x-axis. So I'm going to look at this horizontal axis, and this parabola happens to cross twice. Okay, and it's at these two numbers. So my x-intercepts are at -1, and the next one would be at -3. And if you ever were to write these as a point, it would be -1, 0, and -3, 0, because sometimes you're asked for the coordinates. My y-intercept, like what we looked at before, that's where I cross my y-axis. So when I go to my y-axis and I find that point where I cross, I'm doing that one in green, it crosses at 1, 2, 3. And again, if we're ever asked to write that as a coordinate, that would be the point 0, 3. Now I'm going to pause here for a second, because these two pieces of information I can get right from the forms of my quadratics. So the y-intercept here, what's interesting about that is if we go to the standard form, that y-intercept is always going to be the c. And the reason why is if I were to substitute 0 in for these two x's here in this problem, 0 squared plus 4 times 0, they're both going to equal 0, which leaves me with just this plus 3. So the y-intercept is always going to be the constant that gets added to the end in standard form. As for the x-intercepts, they're going to relate to the numbers inside the parentheses in the factored form, but the signs are different. So in this parenthesis, it says x plus 3, but when I went to my graph, I got a -3. And here, when it was x plus 1, I got a -1 from the graph. The reason why that's happening, remember, is an x-intercept happens when your y is equal to 0. If I were to substitute those two numbers in, like say that -3, well, -3 plus 3 is going to give me 0, and 0 times anything is going to be 0. The same thing would happen here if I were to substitute in a -1 into the other parenthesis. -1 plus 1 gives me 0. 0 times anything gives me 0. And we're going to talk a little bit more about that in the next coming weeks. But if you can remember that in the factored form, the signs would change with your zeros. That's going to help you out a lot. These other two things we're going to find from the graph for right now. So the axis of symmetry, that's the line that goes straight down the middle of your parabola. It cuts it in half. Notice that on either side of that axis of symmetry, I have my roots, my x-intercepts, and they're the same distance. They're all just 1 unit away. So when I write my equation for the axis of symmetry, it's always going to be a vertical line. So I need x equals, in this case, straight up and down, -2 is where it goes through. And it's a vertical line. I really should put arrows on there. So x equals -2. And last but not least, we need that vertex. So the vertex or turning point in this case is our minimum, our lowest point. And it's a point, so we just need the x and the y value. So to get to that turning point, I had to go -2. I went to the left 2, and I went down 1, so that's going to be -1. So those are all the points that you guys found and were looking at from your graphs during those other videos earlier this week. The only thing that we're going to add on to this today is how to find these from just an equation. So we're going to look at finding first our x-intercepts from factored form. So for these examples, we're going to use the same equation. I've got y equals x plus 4 times x minus 2. Okay, so if I'm looking at these, I know right away that my x-intercepts would be -4, and that should be a +2. Okay, so I know that, and I made a little typo there because we're going to wind up changing our sign. Since this is a +4 in here, just like we saw in the last example, that really means my x-intercept is going to be a -4. Since this one is a -2 in the parentheses in factored form, that means that my x-intercept would be a +2. And the reasoning behind that, again, if you were to substitute these numbers in to the parentheses, and I'll do the same one here, well, this parenthesis here, -4 plus 4 gives me 0. 0 times anything, in this case it's -6, that's going to give me 0. Okay, and the same thing would happen here if I substituted my +2 in to my parentheses. Okay, that gives me a 6 in my first one, 2 plus 4. My second one, 2 minus 2, well, there's my 0 again. 0 times anything is 0. Okay, so both of these would give me a y value of 0. If I were to plot these two on my graph, if I have -4 and +2, I know that those are the two places where my graph would have to cross the x-axis. The other thing that I can find from here is where my my axis of symmetry would be. Okay, so if we know that these two, and I have them here, -4 and +2 are the two x-intercepts like what we just drew on the last page, we can find the axis of symmetry. The axis of symmetry would have to be halfway between. So on a graph, we could find it pretty easily. We could count till we got in the middle. There's 1, 2, 3, 4, 5, 6 spaces in between those 2 points. So the axis of symmetry would have to be 3 away from each. So 1, 2, 3, and from here it would be 1, 2, 3. So in this case, it would have to cross at -1. Now, if you were doing it without a graph, because sometimes we're asked to do that, what we could do is basically find the middle by taking the average of those 2 points. So -4 from our first x-intercept here, a +2 from the second x-intercept that we had, and then dividing it by 2 so that way we could find the middle. So the middle would have to be -1. So x equals -1 is the equation for that axis of symmetry. Now, what that axis of symmetry will help us find is the vertex. So, and this is where our good old friend substitution comes back in. So, if we think about this, and I'm just going to do a little sketch. Okay, so if we think about this, our parabola we know is going to kind of sort of look something like this. Okay, where the axis of symmetry goes through the middle. Okay, right through that point. So x equals -1 is that equation that we just found. The vertex lies on that axis of symmetry. Its point The x coordinate is the same as the axis of symmetry. It starts with -1. What we've got to do is figure out what that y coordinate is. So we're going to substitute. We're going to substitute in that -1. So y equals -1 plus 4 times -1 minus 2. Now, if I was in school and had my graphing calculator, I could do that all at once. I'm not. I'm going to do it in pieces. So I've got -1 plus 4 gives me +3. -1 minus 2 gives me -3. Now I just have a multiplication problem left. 3 times -3 is -9. So now I have the y coordinate of that vertex. So my vertex would have to be the point -1, -9. So this is what we're going to be looking at this week and more next week, is looking at these different forms of quadratic equations and what they tell us about their graphs and the relationships they're in. So I hope that this is helpful, and then you guys will be able to use some of this for practice.